My name is Roger Dunn, and this presentation is about using CSV values in a GIS environment. CSV stands for comma separated values, and this presentation is targeted towards the Utah Geographic Information Council attendees of 2018. So a CSV file is a plain text file that can be read by a human. If you look at it here, I am in a very common Windows program called Notepad, and I can see and read the text inside of the CSV. Now, you can configure Windows to use or to look at CSVs in a lot better way, and I'll show you how real quickly. First of all, it's good to turn word wrap off because you want each line to represent one row in this database kind of format. And I also like showing the status bar so I know what row I'm on. For instance, it says line 16, so I'm on row 16. To open a CSV from Windows, you can right-click it and choose Edit, and it should open in Notepad. You might also have Notepad++. You can also see that on my computer, the CSV files are indicated with an Excel icon, which means if I right-click and open or double click, it will open in Excel. We'll do that in just a bit. There's also a way to right click a file and open with, and you can choose Notepad, and then a last way is that you can send to Notepad. Let me show you how to set up the send to option if you like that, because I have several files that I would prefer opening in Notepad rather than their native applications. Using File Explorer, highlight the address bar and type %app data %. That's %APPDATA%. Press Enter and you'll get a list of directories, and I want you to go to Microsoft, scroll down to Windows, double click on Send To. Now I've already got a shortcut for Notepad here, but I'll show you how I did it. Right click within the folder, do New, Shortcut, and type notepad.exe. You can type a name for the shortcut, so I'm going to call it to Notepad, and finish. Now these two really do the same thing, but I had to name it something unique. Now, if I go into a folder with some text files, I can right-click, send to Notepad, and it'll open in Notepad. I'm now going to delete that extra shortcut that I do not need. Okay. So now, let's take a look at what a CSV looks like in Excel. So I'm going to double-click the export. And here it is natively. Every column is the same width, and there are some values that are too wide to display, and so it puts hashtags there. It doesn't do this with text fields, but this is a date field, and it's showing that I don't have enough room. So what I can do to see every value is highlight all the columns and double-click the separator between any two columns. That'll make each column its own width depending on the widest value in that column, as shown here. Now let's take a look at this file in Notepad again, just to do a comparison. In Notepad, you can see that I've got some weird names or texts across the top line. These represent the names of fields that were exported from the database that it came from. Every field name is separated by a comma, thus the acronym CSV. Every row below that represents a row from the database from whence it came. So this must be some sort of ID field, 990. This ADDA field looks like it's an address. The DT field must be this city, and so forth. You'll also notice that the end of many of these rows are 2 commas. Well, why is that? The reason is that because the last 2 fields, this WS and WE, didn't contain any data in the database. So there's 1 comma to separate it from the previous value, and then nothing, which is pretty much like a null, and then after that, another nothing. So it looks like most of the rows exported from the native database did not have values for these 2 fields. On this row, line 11, you can see that there were 2 values. So we have a comma, a date, a comma, and another date. So line 11 is going to correspond to row 11 in Excel as well, right? So here's row 11, and here's those 2 values as I said earlier. Another thing you'll notice in the Notepad version is that there are many double quotes. For instance, on this top line, there's an address of 257 South Vineyard Road. There are 2 quotes around it, but when I look at that same row in Excel, those quotes don't appear there. That's because a computer needs the double quotes to delineate the beginning of a value from the end of it. Without these double quotes, an interpreting computer might think that 257 is the address, S is the city, Vineyard is the street, well, I mean the state, and then road is the zip code and so forth, and it would have problems interpreting it. So these double quotes act as delimiters. Now this double quote character I need to say something about, and that is that it is not the same double quote character used by Microsoft Office programs. If I open Word and start to type a value with double quotes, you'll see a slight difference. The double quotes at the beginning and end of this sentence are slanted, and they're called smart quotes. These don't have the same character value as the ones in Notepad. If I copy this value here and paste it into Word, you can see that those are different characters. If you want to be able to type true double quotes in Microsoft Office, you need to go to File, Options, Proofing, Autocorrect, Auto Format as you type, and uncheck straight quotes with smart quotes. Click OK, and future double quotes that you type won't be smart. Let's see what the CSV looks like in ArcCatalog. I'm going to go to Preview, and it shows me in table form but with some very wide columns, except for the dates. ArcCatalog uses a Microsoft engine to interpret a CSV as a table. If I right-click on the CSV and go to Properties and then Fields, I can see that ArcCatalog thinks that each text field is 8,000 characters wide. This is a far cry from its actual width. In this presentation, I'll show you how to teach ArcMap and ArcCatalog to use the true sizes of these fields. But for now, I'm going to minimize the folder and minimize the program. Before we get to the nitty-gritty of how this is accomplished, we need to find out what the longest values in each column are, and you need Excel to do that. So if you open the CSV in Excel, go to the bottom record by pressing End on your keyboard, and then the down arrow key on your keyboard, and then down one more time. That takes you to the first blank cell beneath all the data. I don't need to know how long the IDs are because those are going to be interpreted as integers, but I do need to know the length of the address field. So here's what I'm going to do. I'm going to type equals max opening parentheses len opening parenthesis, and then I need to type a range. I know I'm in column B, and I know that the top line is really the column header, so I'm going to go for row 2. So B2 colon B, and then I need to know what the row is right above this cell, and that's 188. So I'm going to do 188 and then 2 right parentheses. Now if I just press enter at this point, I'm going to get a value error. And the reason is because Excel wants one argument or one parameter for the len operation. Well, there's a trick that I learned a while ago that is going to help with this. So I'm pressing F2 to be able to edit the cell, and then on my keyboard I'm going to press Control Shift Enter, and something else will happen. You can see down here that I've got a 25 at the bottom, and what it's saying is that the maximum length of any of these addresses is 25 characters. Now I know how long to tell ArcCatalog and ArcMap the field is. If I'd like this for my other fields, I can press Shift Right and go over every string field. These last 3 fields are dates, so I'm not going to cover those. And I'm going to press Control R, which is the same as fill right. Copy and paste would have worked as well. Now I know that the longest city name is 4, the longest state abbreviation is 2, the longest zip code is 5, and then these other 2 fields, which are statuses and types, the longest there is 11. So I'm going to keep Excel up while I mess with something, and that is the schema.ini file. Many of you have seen schema.ini files and wondered what in the world they're for. Well, they are to help the Microsoft engine determine the appearance of CSVs as tables. So here's how they're formatted. This file name has to be complete, including the .csv extension, and it needs to be surrounded with square brackets. Beneath that is the following text: format with a capital F equals CSV delimited, where C, S, V, and D are all capitalized. Beneath that is call name header with C, N, and H capitalized equals true with T capitalized. Hopefully you can see that on the screen. So what I'm going to do now is I'm going to copy and paste the field names that are in Excel into this text file, the schema file. Copy, paste, and I'm going to put each one on its own line. When I copied and pasted them, they were separated by tabs, not commas. Okay, once that's done, I need to tell Microsoft what each of those field types is. I can also give it an alias if I want. I'm going to say call 1 equals, then go down to the next line, call 2 equals, call 3 equals, and COL, it stands for column. Call 5, call 6, call 7. In fact, I think I can change the alias if I just remove the field name that's showing, as long as it becomes a true field name, meaning I can't have spaces in it or have it start with a number. So I'm going to say that column 1 is the same as unique ID, and I'm going to say after that space long to indicate that it's a long integer field. Call 2 is going to be address. Call 3 is going to be city, state, zip, bond type, status, created, start, end, and I need to put in their types at the end. So address space text space width space, and then how long it is, which I find out from the CSV file, 25. 25. The city was text width 4. State was text width 2. The zip was text width 5. Bond type was text width 11. Status, oops, I spelled status wrong. Text width 11. Created is a date, start is a date, and end is a date. File, save. And then back in our catalog, I have to refresh the folder that CSV was sitting in. Now I'll click the same CSV as I did before. I'll click preview, and look at that. All of my column widths are the width that I said that they should be. If I right-click on the CSV and go into Properties, these also agree with what I typed in schema.ini. You can also see that the aliases, by the way, have applied. Now, you probably don't want to work directly with a CSV in ArcGIS and ArcMap. Perhaps you want to convert it to a DBF or a local geodatabase table. Let me show you the advantage of what we've done in this in the export process as a DBase. I'm not going to call it anything because I'm not actually going to perform the export operation, but if you look here in address, right-click, properties, it already knows that it's 25, and so your resulting table is going to have the same width as the CSV was defined as with the schema. Now, for those of you interested in learning more about the schema.ini file, there's a web page on docs.microsoft.com, and the URL is shown here. I can include this URL in the YouTube video description below. Now, many of you also use other tools in conjunction with GIS, and CSVs work with these other tools as well. For instance, let me show you a little script in Python. In Python, you have to import the CSV library. And then in this example, I'm setting a variable to the result of an open command, so that'll open a file of a specific name with read-only permissions. And then I'm going to create a dictionary reader. So a dictionary reader object, or dict reader, is found in the CSV library, and you give it the variable that represents the CSV file. So then I'm going to do a for each command. So for frow in freader, I'm going to print the row. So let's just see what that looks like. Alright, that's a lot of data. So if you look at the format of the data, every row is surrounded by a curly brace and, well, two curly braces, and that's because this represents a dictionary. And inside of the dictionary, we have keys where we have a string, colon, and a string, which is how a dictionary works. Now, this isn't necessarily in the same order that they're defined in the CSV. In fact, the UID field, which was at the beginning, is actually found here at last, and that's because of the way that Python stores dictionary entries. But it's okay. The order doesn't really matter. Over here, I'm going to show how to get specific values of a CSV. So I'm going to comment out print frow, and I'm going to uncomment this print command, which prints frow bracket, and then the address field bracket plus, that's a concatenation operator, a space and a parenthesis, and then again using the dictionary object, the field name for the city, and then a final parenthesis. That's what I'm going to print. So run the module, yes to save, and see, now I've got this sort of format coming out. So whatever GIS operation you need to do, you can access it with the dictionary reader and then perform geoprocessing operations, queries, selects, exports, whatever it is that you need to do. Some of you use PowerShell. So I'm going to open a PowerShell script here in ISE, and I'm just going to run one line at a time because it goes by so fast. So there's no need to import any libraries, but the commandlet that you're going to use is called import -CSV, and I'm going to assign the result of that to the E variable. So great, that's done. Now I'm going to take the E variable and I'm going to pipe it to the select object commandlet, where I'm going to get properties. And here I have a comma separated list of properties: the address, city, what is that, state, and date created. So you can see that I get just those properties from the file, and they're listed in a nice format. This last example of a commandlet in PowerShell uses where objects, so I'm going to filter for all those that don't have a blank address. Sorry, a blank zip code. After I've done filtering them, I'm going to sort them by, what is that, the bond type, and then I'm going to format the whole thing as a table. And now I can see every column from the CSV, and it looks like there are no addresses without a zip code, and it looks like they're sorted by the bond type. So buildings, site plans, subdivision, all alphabetical order. So now let's talk about how to create a CSV. Since CSVs are this kind of format that can share data between programs, there are easy ways for GIS to share its data with other programs. So here I've got a map, a zoning map, and I'm going to add some geocoded points. Now, these geocoded points is a result of the of geocoding the CSV as a DBF, and now it's a shapefile. So the person who sent me this data wants to know what zone each of these addresses are in for these bond projects. So I'm going to do a spatial intersection. We'll do geocoding result, join. We're going to join by spatial location. We're going to join to the Orem zones, and we're going to give it the attributes of that it falls inside. And yeah, let's just put it in our default geodatabase and call it bond zones. Okay, so it's already done. We're going to open the attribute table, and now we've got all these addresses. Now there's a lot of addresses here, sorry, a lot of fields that we don't really need. They came from the geocoder. So we have an option here. We can give the person who gave us the data all of these fields, or we can strip out the unnecessary stuff ourselves and be nice to the person who wanted the data. That's a little extra level of customer service. So how can we delete the fields? Well, one way is to right-click each individual field and delete field, which is time-consuming. We can also go into ArcToolbox and use Data Management, Fields, Delete Field, and we can specify more than one field at once. That's certainly an option. But one way that I like is to delete the fields using Excel, because it's a lot faster operation, and you can also undo in case you didn't mean to delete that field. So let's do that. First things first, we need to get this into a CSV format. So I'm going to go to Table Options, Export, and I'm going to choose All Records, and I'm going to browse, and the type I want is a text file. Now by default, ArcGIS puts TXT as the extension, but you can change that. So I'm going to go into our folder here, and I'm going to say that this is the bond zones.csv. I'm going to click OK. I do not want to add it to the map, but I am interested in opening it in Excel. So here's Excel, here's all these things. So I'm going to delete object ID, the location information, the address stuff from the geocoder, And I'm just going to keep going until I get to the relevant stuff. Alright. So here's the bond ID field that we started with. And then we've got the fields that we got from our zoning layer. So I'm going to press the delete button to delete, what is that, 20, I don't know how many columns are selected, but there's a whole bunch of them. So it's over 26 because it went past Z. So delete. And now I'm just going to keep the zoning information, which is not FID2, delete that. It's not the usage, delete that. It's either going to be the label or the symbol. I bet it's the symbol that we don't want. So delete that. So I'm going to do File. I'm going to save it. It warns me that I'm going to lose some information if I choose CSV. The information that it's talking about is formatting. So I'll just say yes. I'm going to close it, and Excel is going to ask again if I want to save it. And this time I don't need to save because it is saved. So what does that look like? I'm going to right-click Bonds CSV, and I'm going to edit or send to Notepad. And here's what we got. We can safely send this back to the person who sent it to us. They'll be able to read it in whatever programming language or program that they're using, and it'll interpret it, and everything will be hunky-dory. So that's my presentation on CSVs in use with GIS. I hope that you've learned a lot. Leave your comments in the fields below, and we'll talk to you later. Bye.